In 2019, astronomers watched in horror as one of the brightest stars in our sky started dying. Then, something impossible happened. Betelgeuse didn't explode. Instead, this cosmic giant did something we've never seen before. It came back from the dead. This is the story of a star that broke all the rules. A star that should be a supernova right now, lighting up Earth's sky like a second sun. But Betelgeuse had other plans, and what scientists discovered might completely change how we understand the death of massive stars across the universe. To understand why this matters, you need to know something. Betelgeuse isn't just any star. It's a monster, a cosmic time bomb. If you placed it where our sun sits, this red supergiant would swallow Mercury, Venus, Earth, Mars, and reach all the way out to Jupiter's orbit. For thousands of years, humans looked up and saw Betelgeuse shining bright. It marks Orion's shoulder, one of the most recognizable stars we know. Ancient civilizations told stories about it. Sailors navigated by it. Astronomers studied it, thinking they understood its fate. But here's what they knew for certain. Betelgeuse is dying. At roughly 10 million years old, it's already burned through most of its nuclear fuel. Stars like our sun die quietly, fading over billions of years. But massive stars like Betelgeuse, they go out with the universe's loudest bang. A supernova explosion so powerful it can outshine an entire galaxy. For weeks, maybe months, we'd see it during the day. Earth would have 2 suns. Don't worry though, Betelgeuse is 650 light-years away, far enough that the explosion won't harm us. We'd just get the greatest light show in human history. Astronomers have been watching Betelgeuse for decades, tracking its brightness. The star pulses, getting brighter and dimmer in predictable cycles. Dr. Emily Levesque at the University of Washington has studied this star for years. She knows its rhythms, its patterns, its personality. Then, in late 2019, something changed. Betelgeuse started dimming faster than anyone had ever seen, much faster. By February 2020, the star had lost more than 60% of its brightness. It was barely visible to the naked eye anymore. Telescopes around the world swung toward Orion. Social media exploded with speculation. Was this it? Was Betelgeuse about to go supernova? The dimming matched every theoretical model of a star in its final hours. This looked exactly like what we'd expect before the big explosion. Scientists held their breath. Some stayed up all night monitoring the data. Others called colleagues across the globe, sharing observations in real time. Dr. Miguel Montargis, using the Very Large Telescope in Chile, captured images that made his team gasp. The star's surface looked completely different. One entire side of Betelgeuse had darkened dramatically. It was like watching a cosmic wound spread across the star's face. The world waited. News outlets prepared obituaries for a star. Astronomy forums went into overdrive with predictions and theories. And then, just as suddenly as it started, something unexpected happened. In April 2020, Betelgeuse stopped dimming. The star didn't explode. Instead, it started getting brighter again, slowly at first, then faster. By mid-2020, Betelgeuse was back to its normal brightness. By 2021, it was actually brighter than it had been in years. The star that was supposed to die had somehow recovered. It was as if Betelgeuse had looked death in the face and said, "Not today." Scientists were stunned. This wasn't in any textbook. This wasn't supposed to happen. What the hell was going on? Dr. Andrea Dupree at Harvard became obsessed with solving this mystery. She had access to the Hubble Space Telescope, and she wasn't going to waste it. Her team analyzed years of Hubble data, looking for clues. They studied the star's surface, its atmosphere, its behavior before and after the dimming event. What they found was incredible. Betelgeuse hadn't been dying at all. The star had done something far stranger. It had ejected a massive chunk of its own surface into space, a piece of the star itself blown off into the cosmos. This wasn't a small event. We're talking about material with several times the mass of our moon, hurled away at incredible speeds. When that super-hot material hit the cold of space, it cooled and condensed into a massive dust cloud, a cosmic smokescreen. That cloud passed between us and Betelgeuse, blocking our view. It was like the star had pulled a curtain across itself, hiding from Earth. But here's the crazy part. Stars aren't supposed to do this. Not like this. Not at this scale. Sure, dying stars shed material all the time. It's part of their death process. But Betelgeuse had ejected mass like someone coughing up a lung. The violence of the ejection was unprecedented. Computer models struggled to explain how a star could do this without triggering a supernova. Dr. Dupree's colleague, Dr. Klaus Strassmayer in Germany, had another piece of the puzzle. His observations showed massive convection cells on Betelgeuse's surface. Imagine bubbles of plasma the size of Earth's orbit, rising and falling beneath the star's surface. These aren't gentle movements. One of these convection cells had apparently punched through the star's outer layers, carrying material into space like a cosmic eruption. The force required was mind-boggling. We're talking about energies that make our sun's biggest solar flares look like birthday candles. As the dust cloud dissipated, Betelgeuse emerged, wounded but alive. The star had literally lost part of itself, but kept on burning. Now, scientists had to rethink everything. If Betelgeuse could survive this, what else were we wrong about? The discovery raised uncomfortable questions. How many times had this happened before? How many times could a star do this before finally exploding? Dr. Levesque put it perfectly. We thought we understood red supergiants. Betelgeuse just taught us we've been reading the wrong book. But the mystery deepened. Other observations suggested something even stranger might be happening inside the star. Some astronomers propose that Betelgeuse might be going through a phase called shell helium burning, a last burst of nuclear fusion before the end. If true, this could mean the star is much closer to explosion than we thought, maybe decades instead of thousands of years. Or maybe the ejection event had somehow delayed the inevitable, giving Betelgeuse more time. A cosmic life extension. Meanwhile, another team using ALMA telescope in Chile found evidence of asymmetric mass loss. The star wasn't just losing material randomly. Betelgeuse seemed to be ejecting more mass from certain regions than others. Like a balloon with weak spots, leaking air unevenly. This asymmetry could explain why the dimming was so dramatic. We happened to be looking at the side where the ejection occurred. From another angle in the galaxy, aliens would have seen a completely different show. Or maybe no show at all. Dr. Montargis continued his observations, watching the star's surface roil and bubble. Betelgeuse was restless, unstable, unpredictable. In 2023, the star dimmed again. Not as dramatically as before, but enough to make astronomers nervous. Was it happening again? This time, scientists were ready. Multiple telescopes tracked every wavelength, capturing data in unprecedented detail. The second dimming turned out to be different, more regular, more predictable, just the star's normal pulsation cycle, amplified. But it proved something important. Betelgeuse was still volatile, still capable of surprises, still very much on the edge. Here's what we know now. Betelgeuse is in the final stages of its life. That part hasn't changed. The star has maybe 100,000 years left, possibly much less. In cosmic terms, that's a blink. It could explode tomorrow or in 1,000 years. When it does go supernova, it will be spectacular. For a few months, we'll be able to see it clearly, even in daylight. Ancient petroglyphs and records will pale in comparison. This will be the astronomical event that defines our generation. But the 2019 event taught us something profound. Even dying stars can fight back. Even cosmic time bombs can surprise us. Betelgeuse's recovery revealed how little we truly understand about stellar death. The process is messier, more chaotic, more resilient than we imagined. Other red supergiants might be doing the same thing. We just haven't been watching closely enough, or we missed the signs. Dr. Dupree's team is now monitoring other red supergiants, looking for similar behavior. Antares, Mu Cephei, VY Canis Majoris. If this is a common phase of stellar death, we need to rewrite the textbooks. We need to update our models of how massive stars end. The implications go beyond just understanding Betelgeuse. Supernovae seed the universe with heavy elements: carbon, oxygen, iron, gold. Everything in your body except hydrogen came from stars like Betelgeuse. Understanding how they die helps us understand how we came to exist. There's another fascinating angle. Could this behavior extend a star's life? Could massive ejections delay the final explosion? If a star can shed mass before going supernova, it might change the explosion itself, make it bigger, smaller, or qualitatively different. These questions matter for understanding supernovae across the universe, for measuring cosmic distances, for studying dark energy itself. Betelgeuse also changed how we think about observing stars. We can't just look at brightness anymore. We need to see the surface, the atmosphere, the surrounding space. New technologies are coming online that will help. The extremely large telescope in Chile will see unprecedented detail when it opens. Future space telescopes will monitor stars continuously, catching events we used to miss. No more surprises like Betelgeuse blindsiding us. But here's the beautiful thing about science. Sometimes the best discoveries come from being wrong. We thought Betelgeuse was about to explode. We were wrong. And in being wrong, we learned something far more interesting. The universe doesn't follow our scripts. It doesn't care about our models or predictions. It just does its thing, and we get to watch in awe. So what happens next with Betelgeuse? Honestly, nobody knows. That's what makes it so exciting. The star could eject more material. It could brighten further. It could dim again. Or, yes, it could finally go supernova. Astronomers are watching constantly now. Betelgeuse has earned permanent surveillance status. We're not getting caught off guard again. Amateur astronomers have joined the effort too. Thousands of people around the world monitor Orion, reporting brightness changes. It's become a global collaborative project. When Betelgeuse finally does explode, we'll have more data than any supernova in history. Dr. Levesque keeps a packed bag ready. When the star goes, she wants to get to the largest telescopes immediately. Other astronomers have similar plans. There are observation protocols, alert systems, coordinated campaigns ready to activate at a moment's notice. The James Webb Space Telescope has Betelgeuse on its target list. Its infrared eyes will see through any dust clouds the star produces. Neutrino detectors deep underground are primed to catch the first warning signs. When fusion stops in the core, neutrinos escape first. We'd know Betelgeuse was exploding hours before we saw the light. Time to point every telescope on Earth toward Orion. But until that moment comes, Betelgeuse keeps burning, a dying star that refused to die. At least, not yet. It's out there right now if you want to see it. Go outside on a clear night, find Orion the Hunter, look at his left shoulder. That reddish star, slightly brighter than the others, that's Betelgeuse. A monster star in its death throes, still shining bright. You're seeing light that left that star 650 years ago, before Columbus sailed to America, before the Renaissance began. For all we know, Betelgeuse might have already exploded. The light just hasn't reached us yet. We could walk outside tomorrow night and see a new, brilliant star in the sky, brighter than Venus, casting shadows at midnight. Or Betelgeuse might keep defying expectations, surviving for thousands more years, outlasting our predictions again and again. Either way, this star has taught us humility. The universe is stranger, more complex, more wonderful than we ever imagined. So keep looking up, keep watching Betelgeuse, because when this cosmic giant finally decides to go, we're all going to witness something truly extraordinary.